So hello students, today we are going to discuss about general solution. First of all, let us try to understand what is a general solution. What do we actually mean by general solution? Okay, we are speaking about trigonometric equation like this. Sin theta is equal to 0. Okay, this is a trigonometric equation. Okay, what is the solution of this equation? All of you will say that sin theta is equal to 0 has the solution theta is equal to 0. Yes, you are right. But let's think, what is a solution? A solution is the value of the variable which satisfies the equation. A solution is a value of the variable which satisfies the equation. Okay, if we put theta is equal to 0 in this equation, yeah, it satisfies the equation. Okay, what if we put theta is equal to pi? What is the value of sin pi? We all know value of sin pi is 0. What is the value of sin twice pi? If you apply ASTC, you will get that sin twice pi is also 0. What is the value of sin thrice pi? Sin thrice pi is also 0. Then what's about these values? Pi, twice pi, thrice pi, even sine of minus pi. Sine of minus pi is equal to minus sin pi is equal to 0. So theta is equal to minus pi, theta is equal to pi, theta is equal to twice pi, theta is equal to minus twice pi, theta is equal to 3 pi, theta is equal to minus 3 pi. All those values also satisfy the equation. So they must also be solutions of the equation. But when you are asked what is the solution of sin theta is equal to 0, you say theta is equal to 0. Okay, so the solution set which gives all the possible solutions of a trigonometric equation is called general solution of that equation. Okay, when we speak about general solution, it means a set of solutions. Okay, all those solutions, all those value of the variable which satisfy the equation is called general solution. Alright, so general solution is the set of values of the variable which satisfy a given trigonometric equation. Alright, so there is general solution. Actually, trigonometric functions are periodic functions. Okay, they take the same value after a particular period. They take the same value after a particular period. So you will get infinite number of solutions of a trigonometric equation. Okay, when we give all the solutions as a set, that solution is known as general solution. Now we will try to find general solutions of some standard equations. For that we need a unit circle. Okay, what is a unit circle? A unit circle is a circle whose radius is unity. A unit circle is a circle whose radius is unity. So I have taken here a circle whose radius is 1. Unity means 1. So its radius is 1. Suppose there be a point whose coordinate is x. So it's a plane, so every point has its coordinate. So let there be a point on the circle whose coordinates are xy. Okay, and if we join this point with the center O here, as you see here, this is the point O, is the center of the circle. If we join this point O with that point pxy, suppose this is pxy, let it makes an angle theta with positive direction of theta with x-axis. Okay, now from coordinate geometry you know that this length up to that foot of the perpendicular is x. If the point is xy, then this length is x and this length is y. Okay, let us give this point a name M. We give a name to this point M. So in the triangle OPM, OM is x and PM is y, and this angle POM is theta. Now, and length of this radius is 1 unit. Okay, now we see OM by PM is equal to cos theta. OM by PM is equal to cos theta, adjacent by hypotenuse, cos theta. Now the length of PM is 1 and OM is x. So we get x equal to cos theta. again OM by OP, sorry, OM by OP, length of OP is 1, so OM by OP, OM is x, OP is 1, so x equal to cos theta. Again you see PM by OP, PM by OP, that is opposite by hypotenuse, is sin theta. Now PM is 1 and OP is 1 is equal to sin theta. So we see that every point xy, I have taken an arbitrary point xy, wherever you may take, every point xy can be expressed as cos theta, sin theta. X coordinate corresponds to cos theta and y coordinate corresponds to sin theta. In a unit circle, every point corresponds to cos theta, sin theta for some value of theta. Okay, so x coordinate corresponds to cos theta and y coordinate corresponds to sin theta. Now let us erase these things, we don't need it. Okay, now so have you got the point? Every point in a unit circle can be expressed in the form cos theta, sin theta for some value of theta. Now let us try to solve some standard equation. Number 1, our first equation is sin theta is equal to 0. As discussed, so first equation is sin theta is equal to 0. As discussed, sin theta means y. Y equal to 0. That means sin theta is equal to 0 corresponds to a point whose y coordinate is 0. Where is y coordinate 0? We all know that on x-axis y is 0. So y equal to 0 is the equation of x-axis, and every point on the x-axis has its y coordinate 0. So this will lie on the x-axis. Okay, that solution will lie on the x-axis. But the point is a point of the circle. So it will lie on x-axis where the circle cuts the x-axis. So the solution set will be at the point A and at the point C. Did you get it? Sin theta is equal to 0 means y equal to 0. Y equal to 0 lies on x-axis, and we have taken sin theta equal to 0 is a point on the circle. Okay, is a point on the circle as we discussed earlier. Point on the circle. So it will lie on x-axis where the circle cuts the x-axis. That means it will be at the point A or at the point C. So solution corresponds to the point A and C. Okay. So theta will be given by the points A and C. Now at the point A, we start rotating from the point A. This is the initial point. So theta will be 0 here. Then we complete one revolution. Then theta will be pi, twice pi here, 0, then twice pi. Then after another revolution in anti-clock direction, it will be 4 pi. Another revolution, it will be 6 pi, and it will go like that. If we revolve in clock direction, 0, then minus twice pi, then minus 4 pi, then minus 6 pi, then minus 8 pi. So it will go like that. Okay. And at the point C, you see, when we rotate in anti-clock direction, at the first revolution, here it is pi, pi. Then 2 pi, again here it is 3 pi. Then 4 pi, then 5 pi. Okay. And it will go like that. Okay. You will keep revolving and the value of theta will go increasing. If we rotate in anti-clock direction from the point A, then the first angle here will be minus pi. Okay. In clock direction, angle is negative, so it will be minus pi, then minus twice pi, then minus thrice pi, then again minus 4 pi, minus 5 pi will be here. So the angles here are pi, thrice pi, 5 pi, minus thrice pi, minus 5 pi, dot, 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 like that. Okay. So what are the values of theta? At the point C, it is 0. Then we come, sorry, at the point A it is 0. Then we come to C, it's pi. Then again we come to A, it's twice pi. Then again at C, it's thrice pi. Okay. Then 4 pi and so on. In the negative direction, it's minus pi, first revolution. Then minus twice pi. Then minus thrice pi and so on. So we can simplify these angles as 0 plus 1 plus plus 1 minus 1 pi plus 2 minus 2 pi plus 3 minus 3 pi and goes on up infinity. Alright? Again, we can say that this is n pi where n is an integer. You see, here all the values are integers. 0 into pi, plus minus 1 into pi, plus minus 2 into pi, plus minus 3 into pi, all these are, and dot 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 dot, all these are integers. So in general we can say that some integer into pi where n is an integer, n pi n is an integer. So this is the general solution of sin theta equal to 0. Okay, you have to remember this solution. Sin theta is equal to 0, solution is theta is equal to n pi. Next equation is cos theta equal to 0. Cos theta means what? X coordinate. Okay, we got x equal to cos theta, y equal to sin theta. So cos theta is equal to 0 means x equal to 0. X equal to 0 means the point lie on y axis, and the solution will be at the point on y axis where the circle cuts y axis. So the solution corresponds to B point and D point. So the solution corresponds to the points B and D. Okay. Now we see what are the values of theta at B and D. During our first revolution in anti-clock direction, here pi by 2, okay, at the point B, then 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2, 6 pi by 2, 7 pi by 2, 8 pi by 2, here again 9 pi by 2. So it will go like that, pi by 2, 5 pi by 2, 9 pi by 2, 13 pi by 2, 17 pi by 2, dot dot dot. In the clock direction, so minus pi by 2, minus 2 pi by 2, at the point B it is minus 3 pi by 2. Then minus 4, minus 5, minus 6, minus 7 pi by 2. Alright? Then minus 11 pi by 2, then minus 15 pi by 2. So at the point B it is pi by 2, 5 pi by 2, 9 pi by 2, 11 pi, 13 pi by 2, 17 pi by 2, dot dot dot. In this direction it is minus 3 pi by 2, minus 7 pi by 2, dot 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 dot. Okay? At the point D, the solution also corresponds to the point D. At the point D, in anti-clock direction during our first revolution, pi by 2, 2 pi by 2, 3 pi by 2. First angle here is 3 pi by 2. Then 4, 5, 6, 7 pi by 2. Then 8, 9, 10, 11 pi by 2. So next will be 15 pi by 2, then 19 pi by 2, and goes on like that. Okay. Now in the clock direction, it is minus pi by 2, then minus 2 pi by 2, minus 3 pi by 2, minus 4 pi by 2, minus 5 pi by 2, then minus 6 pi by 2, 7, minus 7, minus 8, minus 9 pi by 2, then minus 13 pi by 2, then minus 17 pi by 2. It will go like that. Okay. So what are the values of theta at B and D? We will write now. It is pi by 2, here pi by 2, then we come here 3 pi by 2, then 3 pi by 2, then here 5 pi by 2. We are taking the values from B and D. Okay? Then 7 pi by 2, dot 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 dot. And the negative angles are here first minus pi by 2, then minus 3 pi by 2, then minus 5 pi by 2, and so on. Okay? So if we organize the values, it is plus minus pi by 2, plus minus 3 pi by 2, plus minus 5 pi by 2, and so on. Okay? So what are these? These are odd multiples of pi by 2, odd integral multiples of pi by 2, odd integer into pi by 2. And an odd integer can be written as twice n plus 1 pi by 2 for n belongs to z. Okay? What are the values of integer? 0, plus 1, minus 1, plus 2, minus 2. So if we put here 0, we will get pi by 2. 0 in place of n, then we will get pi by 2. 1 in place of n, we will get 2 into 1 plus 1, that is 3 pi by 2. 2 in place of n, we will get 5 pi by 2. 3 in place of n, we will get 7 pi by 2. If we put minus 1 here, then minus 2 plus 1, that is minus pi by 2. minus 2, if we put n is equal to minus 2, then minus 4 plus 1, that is minus 3 pi by 2. If we put n is equal to minus 3, then it will be minus 5 pi by 2. Okay, and so on. So, the general solution of cos theta is equal to 0 is twice n, theta is equal to twice n plus 1 pi by 2, n belongs to z. That is odd multiple of pi by 2. Okay, next equation is say sin theta is equal to 1. This is the third equation. Sin theta is equal to 1. Sin theta means y. So y is equal to 1. So where is y 1? You see, the circle is unit radius circle. Its radius is 1. So this length is 1. Here y is equal to 1. And nowhere on the circle you get y is equal to 1. So y is equal to 1 corresponds to the point B. Do you get my point? Radius is 1. Okay. So our y should be 1. Here y is not 1. Here y is 1. The whole radius. We are getting the whole radius. So here the value of y is 1. Here the value of y is minus 1. So sin theta is equal to 1 corresponds to y is equal to 1. And y is equal to 1 corresponds to the point B. So solution is at the point B. So what are the values of theta? Theta is equal to pi by 2. 5 pi by 2, all the values at the point B, then 9 pi by 2, minus 3 pi by 2, minus 7 pi by 2, okay. So all these are solutions. Okay. We may have a general representation of that. Pi by 2, 5 pi by 2, if we put theta is equal to 4n plus 1 pi by 2. We may put here theta is equal to 4n plus 1 pi by 2, n belongs to z. Okay. How? If we put n is equal to 0, the value will be pi by 2. If we put n is equal to 1, 4 plus 1, that is 5 pi by 2. If we put n is equal to 2, it will be 9 pi by 2. If we put n is equal to minus 1, then minus 3 pi by 2. If we put n is equal to minus 2, then it will be minus 7 pi by 2. Okay. In this way, we will get all solutions from this representation. Theta is equal to 4n plus 1 pi by 2, n belongs to z. Next, cos theta is equal to 1. Cos theta means x equal to 1. Can you find where x equal to 1? Perfect. You see, here x equal to 1. Okay, here x is not 1, here x is not 1, here x is 0 at the point B, and at this point x is equal to 1. Okay, so our solution corresponds to the point A. What is the value of theta at the point A? At the point A, value of theta are 0, plus 2 pi, minus 2 pi. So we can write plus minus 2 pi, then plus minus 4 pi, then plus minus 6 pi, and so on. So what are these? These are even multiple of pi. Isn't? These are even multiple of pi. 0, plus minus 2, plus minus 4, plus minus 6. So we may write theta is equal to twice n pi. Theta is equal to twice n pi. N belongs to z. So this is the general solution of the equation cos theta is equal to 1. Next, sin theta is equal to minus 1. That means theta is equal to minus 1. So where is theta minus 1? Where is theta minus 1? At this point D. So our solution set corresponds to the point D. And at the point D, values of theta are 3 pi by 2. You see here at the point D, 3 pi by 2, 7 pi by 2, 11 pi by 2, and so. Then minus pi by 2, minus 5 pi by 2, minus 9 pi by 2, values can be represented in general as theta is equal to 4n minus 1 pi by 2. So this is the general solution of sin theta is equal to minus 1. General solution of sin theta is equal to minus 1 is theta is equal to 4n minus 1 pi by 2. So our next equation will be which number is this? 4, 5, 6. Okay, this one is 5. Cos theta is equal to minus 1. Cos theta is equal to minus 1, that means x equal to minus 1. Where is x minus 1? Here x is minus 1. So the solution corresponds to the point C. What are the values of theta at the point C? You see, pi, minus pi, 3 pi, minus 3 pi, 5 pi, minus 5 pi. So we may write plus minus pi, plus minus 3 pi, plus minus 5 pi, plus minus 7 pi, and so on. So what is this? These are odd multiples of pi. So theta can be written as odd number twice n plus 1 pi for n belongs to z. So general solution of the equation cos theta is equal to minus 1 is theta is equal to twice n plus 1 pi, n belongs to z. Now tan theta is equal to 0, next equation will be 7 perhaps. Tan theta is equal to 0. Okay. Tan theta is equal to 0. Tan means sin theta by cos theta. This implies sin theta is equal to 0, and sin theta is equal to 0 has the solution theta is equal to n pi and belongs to 0. So general solution of tan theta is equal to 0 is theta is equal to n pi and belongs to 0. General solution of sin theta is equal to 0 and tan theta is equal to 0 are the same. Next, tan theta is equal to 1. This implies sin theta is equal to tan theta means, okay, we will solve it later. Tan theta is equal to 1. Okay, up to this. So we have found the solution of sin theta is equal to 0, cos theta is equal to 0, tan theta is equal to 0, sin theta is equal to 1, cos theta is equal to 1, sin theta is equal to minus 1, cos theta is equal to minus 1. Now we will try to solve some general equations, general structure. Suppose sin theta is equal to sin. What is this? Value of sin theta is not only 0, 1 and minus 1. It may take any value between minus 1 and plus 1. As you all know, sin theta takes all the values between minus 1 and plus 1. So it may be half, it may be root 3 by 2, it may be 2 by 3, any value. So for that type of equations, we need this structure. Sin theta is equal to sin. This implies sin theta minus sin alpha is equal to 0. Let us apply here sin c minus sin t formula. Sin c minus sin t is 2 cos c plus d by 2 into sin c minus d by 2. So either this equal to 0 or that equal to 0. Therefore, cos of theta plus alpha by 2 is equal to 0, or sine of theta minus alpha by 2 is equal to 0. You don't need the circle. Now we know solution of cos theta is equal to 0. What is the solution of cos theta is equal to 0? Solution of cos theta is equal to 0 is theta is equal to twice n plus 1 pi by 2. So here theta means theta plus alpha by 2. Therefore theta plus alpha by 2 is equal to twice n plus 1 pi by 2. Now by 2 cancel. Theta is equal to twice n plus 1 pi. So theta plus alpha This implies theta is equal to twice n plus 1 pi minus alpha n belongs to z. N belongs to z. Alright? Okay. Now what's about this? This is of the form sin theta is equal to 0, and the general solution of sin theta is equal to 0 is theta is equal to n pi. This implies theta minus alpha is equal to twice n pi, n belongs to z. This implies theta is equal to twice n pi plus alpha, n belongs to z. So we have got two solutions, two sets of solutions. One is twice n plus 1 into pi minus alpha, and another is twice n pi plus alpha, n belongs to z. So twice n plus 1 is odd, it will be 1, 3, 5 like that, and twice n is even. So if it is odd multiple of pi, then alpha has the minus sign. If it is even multiple of pi, then alpha has the plus sign. Considering this and combining these two, we can write a single expression, n pi plus minus 1 to the power n into alpha, n belongs to z. How? You see, this expression is representing these two expressions. How? If we put any even value, say n is equal to 2, then it will be minus 1 square, so this will be plus alpha. For even, it is plus alpha. 4 minus 1 to the power 4 is plus. 6 minus 1 to the power 6 is plus. So even multiple of pi, then alpha has the plus sign. If we put any odd value for n is equal to 1, minus 1 to the power 1 is minus, so n pi minus alpha, odd multiple of pi minus alpha, twice n plus 1 is odd, thrice pi minus alpha, minus 1 to the power 3 is minus, minus 1 to the power 5 is minus. So combining these two, we can write theta is equal to n pi plus minus 1 to the power n into alpha. Thus, general solution of sin theta is equal to sin alpha is theta is equal to n pi plus minus 1 to the power n into alpha, n belongs to z. Now let us solve cos theta is equal to cos alpha. Is equal to cos alpha. This implies here theta is the variable, alpha is a constant, is equal to 0. We apply cos c minus cos d. What is the formula for cos c minus cos d? 2 sin c plus d by 2 into sin d minus c by 2. Alright? We know sine of minus theta is equal to minus sin theta. We can take a minus sign from here, and this will become minus 2 sin theta plus alpha by 2 into sine of theta minus alpha by 2 is equal to 0. Taking minus sign from here, sine of minus theta is equal to minus sin theta. Therefore, either this is equal to 0 or this is equal to 0. Therefore, sine of theta plus alpha by 2 is equal to 0, or sine of theta minus alpha by 2 is equal to 0. So what is the solution of sin theta is equal to 0? Sin theta is equal to 0 is theta is equal to n pi. Therefore, theta plus alpha by 2 is equal to n pi. N belongs to 0. This implies theta plus alpha is equal to twice n pi. This implies theta is equal to twice n pi minus alpha, n belongs to z. What is the solution? This is again of the form sin theta is equal to 0. Sin theta is equal to 0 implies theta is equal to n pi, n belongs to z. This implies theta minus alpha is equal to twice n pi, n belongs to z. This implies theta is equal to twice n pi plus alpha, n belongs to z. So the solutions are theta is equal to twice n pi minus alpha, or theta is equal to twice n pi plus alpha, n belongs to z. Combining these two, we can write theta is equal to twice n pi plus or minus alpha, n belongs to z. This single expression is representing the above two expressions. So the general solution of cos theta is equal to cos alpha is theta is equal to twice n pi plus or minus alpha. Next, you don't have to find the reduction of the equation. Solution is not needed. You are to remember the solution only. As formula, we will remember the solutions corresponding to the equations. Next equation is tan theta is equal to tan alpha. Tan means cos theta, sin alpha by cos alpha. Okay, cross multiplying sin theta cos alpha is equal to cos theta sin alpha. This can be written as sin theta cos alpha minus cos theta sin alpha equal to 0. This implies sin of theta minus alpha is equal to 0. Sin A cos B minus cos A sin B sin of A minus B. And the solution of sin theta is equal to 0 is theta is equal to n pi, n belongs to z. This implies theta is equal to n pi plus alpha, n belongs to z. Thus, the general solution of tan theta is equal to tan alpha is theta is equal to n pi plus alpha, n belongs to z. Next, tan theta is equal to 1. Implies tan theta is equal to, we know tan 45 degree is 1, tan theta is equal to tan pi by 4. In place of 1, we can write tan pi by 4. Now this is of the form tan theta is equal to tan alpha. And what is the general solution of tan theta is equal to tan alpha? General solution of tan theta is equal to tan alpha is 4n plus pi by n pi plus alpha. Here alpha is pi by 4, so theta is equal to n pi plus pi by 4, n belongs to z. Taking LCM, we can write this as 4n pi plus pi by 4. And that can be written as 4n plus 1 pi by 4, n belongs to z. So general solution of tan theta is equal to 1 is 4n plus 1 pi by 4, n belongs to z. General solution of sin theta is equal to 1 is 4n plus 1 pi by 2, n belongs to z. General solution of tan theta is equal to 1 is theta is equal to 4n plus 1 pi by 4, n belongs to z. Then tan theta is equal to minus 1, tan theta is equal to minus tan pi by 4, tan theta is equal to tan of minus pi by 4. We know that tan of minus theta is equal to minus tan theta. So this is of the form tan theta is equal to tan alpha. So the solution is theta is equal to n pi plus alpha. What is alpha here? Here alpha is minus pi by 4. So on simplification, taking LCM, this will become, let me write it straight, 4n minus 1 pi by 4, n belongs to z. The general solution of tan theta is equal to minus 1 is 4n minus 1 pi by 4, n belongs to z. It has similarity with sin theta is equal to minus 1. General solution of sin theta is equal to minus 1 is 4n minus 1 pi by 2, n belongs to z. So these are the 12 formulae you have to remember. You may have a summary in your class book. You may see class book page number 74. Let me show you. Class book page number 74. Here is a table. Sin theta is equal to 0, theta is equal to n pi. Okay, then you write tan theta is equal to 0, theta is equal to n pi. Where is tan theta is equal to 0? Yeah, here it is. Tan theta is equal to 0. Theta is equal to n pi. Okay, this will help you remember the formula. Then sin theta is equal to 1. Theta is equal to 4n plus 1 pi by 4, pi by 2. You see here, sin theta is equal to 1, theta is equal to 4n plus 1 pi by 2, n belongs to z. Then you write tan theta is equal to 1, theta is equal to 4n plus 1 pi by 4, n belongs to z. You see it here at my fingertip. Okay. Then sin theta is equal to minus 1, theta is equal to 4n minus 1 pi by 2. You see here, number 8. Then you write tan theta is equal to minus 1, theta is equal to 4n minus 1 pi by 4, n belongs to z. This similarity will help you remember the formulae. Then you write the formulae for cos. Cos theta is equal to 0, theta is equal to twice n plus 1 pi by 2, n belongs to z. Yeah, here it is. Number 2. Okay. Number 2 at my fingertip. Then cos theta is equal to 1, theta is equal to twice n pi. Number 9. Then cos theta is equal to minus 1, theta is equal to twice n plus 1 pi. Yeah. Then number 10. Cos theta is equal to minus 1, theta is equal to twice n plus 1 pi, n belongs to z. Alright. So these are the formulae for general solutions. Now, to solve a general solution, to find the general solution of a given trigonometric equation, you have to remember some points. These points are given in your class book. You see page number 73. Class book page number 73, at the bottom of the page there are some notes. You can see it here. There are some notes. Okay. These are very important notes. You have to remember these notes. What are these? The first one is, you will get various type of equations in terms of sine, in terms of tan, in terms of sec, in terms of cosec, in terms of cot. Every ratio may be there. But whatever be the equation, you have to reduce it by algebraic simplification. You have to reduce it to one of the forms: sin theta is equal to sin alpha, or cos theta is equal to cos alpha, or tan theta is equal to tan alpha. Okay, your reduced form may be sin, cos, or tan. Okay, we know formula for sin, cos, or tan. So we will reduce them to sin theta is equal to sin alpha, cos theta is equal to cos alpha. That means sin theta is equal to sin of something, or cos theta is equal to cos of something, or tan theta is equal to tan of something. Okay, by algebraic simplification you will reduce the equation to these three standard forms. Then number 2, so you have to do algebraic simplification of the trigonometric equation. During algebraic simplification you will take different steps. Okay, different types of simplifications will be there. You will cross multiply, you will square both sides like this. Okay, due to these simplifications, what happens sometimes, the original equation and the reduced equation may not have the same solution. Sometimes the solutions, there comes some solutions of the reduced equation which does not satisfy the given equation. Let me show you an example. Suppose we are given sin theta is equal to 1. Okay. Now let me square both sides. Sin square theta is equal to 1. Is there anything wrong? No. Now again taking square root, sin theta is equal to plus or minus 1. Now, so the equations are sin theta is equal to 1 and sin theta is equal to minus 1. Okay? But value of sin theta is not minus 1. Okay, you see. So sin theta is equal to 1 has the solution 4n plus 1 pi by 2, n belongs to z. And sin theta is equal to minus 1 has the solution theta is equal to 4n minus 1 pi by 2, n belongs to z. If we put n is equal to 0 here, we will get theta is equal to minus pi by 2 as a solution, but theta is equal to minus pi by 2 won't satisfy the equation. So logically you have not mistaken, but there are some solutions which does not satisfy the original equation. The solution of this reduced equation does not satisfy the original equation. Such type of solutions are called extraneous solutions. What solution? Extraneous solutions. Such type of solutions are called extraneous solutions. So due to algebraic simplification, there may come some solutions which will not satisfy the original equation. Okay, this type of solutions are called extraneous solution, and you have to reject those solutions. Okay, after verification we have to reject the solution. And this type of solutions generally come due to squaring of both sides. So remember one thing, you never square both sides of the equation. For simplification, we will never square both sides. Whenever you will square both sides, there will be some external solution, and it's very tough to find out those external solutions. So we will try avoiding those external solutions. How can you avoid the external solutions? You have to take one precaution: don't square both sides. Remember that, don't square both sides. Okay. So this is your second note. Then the third note. To solve an equation, we generally, what we do, we generally we cancel some terms. Suppose an equation is ax equal to 4a, x is the variable here and a is a constant. We have to find the value of x. What will we do? We write x equal to 4. Just by cancelling a, we get the solution. This is called cancellation. Okay. So what happens sometimes, due to cancellation, we may lose some of the required equation. Okay. Due to cancellation, we may lose some of the required equations. So what precaution can we take so that we don't lose the equations? Okay. The precaution here is, you don't, before cancellation, you make it sure that the quantity cancelled is not 0. Here I have cancelled a, but before cancellation I have to think that is a 0? Is there any possibility of a to be 0? If there is a possibility that a is 0, then you cannot cancel. Okay, you cannot cancel that a. Suppose we have an equation sine 2 theta is equal to sine theta. We have an equation sine 2 theta is equal to sine theta. Now you see, on expansion, sine 2 theta is 2 sine theta cos theta. Now, unknowingly, if we cancel sine theta from both sides, this will become 2 cos theta is equal to 1 by cancelling sine theta from both sides. Okay, this will imply cos theta is equal to half. Okay, this will imply cos theta is equal to cos pi by 3. This will imply theta is equal to, what is the general solution of cos theta is equal to cos alpha? General solution of cos theta is equal to cos alpha is twice n pi plus minus pi by 3. Okay. We found the solution. But what we have mistaken here? What? I have cancelled sin theta from both sides without thinking. So you must give a thought here. Before cancelling that sin theta, I must have thought that, can sin theta be 0? Okay. How can and how cannot? Can sin theta be 0? How can I verify it? If sin theta is equal to 0, does it satisfy the equation? If one sin theta is equal to 0, does it imply left hand side is equal to right hand side? You see, if sin theta is equal to 0, then this side will be 2 into 0 into cos theta, that means 0. If sin theta is equal to this side is also 0, 0 is equal to 0, that means it's satisfying the equation. If it satisfies the equation, you cannot cancel it. So you cannot cancel. What you have to do? You have to write here sin theta is equal to 0, and this will yield another set theta is equal to n pi. So if you cancel sin theta unknowingly, you will miss this set of solution and the answer will be incorrect. Okay, you have both the risk, losing equations or giving some extra solutions. Losing solutions or giving some extra solutions. Both are dangerous. So be cautious. Before cancellation, make it sure that the quantity cancelled is not 0. That means, if we take that quantity is equal to 0, does it satisfy the equation? You have to verify it. If it satisfies the equation, you cannot cancel it from both sides. Okay? You will factorize and separately take both the terms as quantities as 0. This is the rule. Okay. So this is the third. Next, the fourth. The equation will be given in defined forms. Okay. So what we do? We reduce the equation either to sin theta is equal to sin alpha, or cos theta is equal to cos alpha, or tan theta is equal to tan alpha. So different student will take different approach. Someone will approach to sin theta is equal to sin alpha, someone will approach to cos theta is equal to cos alpha, someone may approach to tan theta is equal to tan alpha. The same equation may have different approaches, and in that case, one who has approached to the form sin theta is equal to sin alpha will have solution in this structure, theta is equal to n pi plus minus 1 to the power n into alpha. And one who has approached towards tan theta is equal to tan alpha will have his solution in the form theta is equal to n pi plus alpha. One who has approached towards cos theta is equal to cos alpha will have the structure theta is equal to twice n pi plus minus alpha. Okay, defined person will have defined answers. Okay, you see their looks will be different. Their looks will be different. One have the term minus 1 to the power n, where here minus 1 to the power n is missing. Here minus 1 to the power n is missing. One will have n pi, another will have twice n pi. So their looks will be different. Okay, but if they put all the integral values of n, if they put n is equal to 0, n is equal to 1, n is equal to minus 1, then they will get a set of solutions. That set of solutions will be same. So what we learn, the looks of the answer may be different, but the answer will be may be correct. For both of them, the answer may be correct. Okay, so this is another thing. Next, okay. Now you write here, these things are not written in the book. You write these points. So we have discussed 4 points. This is our 5th point. Okay. This is our 5th point. In an equation, there may come expression like this. While solving, we get it. Tan theta is equal to minus 1. There was minus 10 pi by 4. So in that case, we write minus tan alpha is equal to tan of minus alpha. If we get minus sine alpha, we will write sine of minus alpha. If we get minus cos alpha, we will write cos of pi minus alpha. Okay. For minus tan alpha, we will write tan of minus alpha. For minus sine alpha, we will write sine of minus alpha. For minus cos alpha, we will write cos of pi minus alpha. Then the 6th point, if an equation involve both tan and cot with the same angle, then we express cot in terms of tan. Okay. If an equation involves both tan and cot with the same angle, if there is tan theta and cot theta, both are theta, then what we will do? We will write cot theta as 1 by tan theta. But if an equation involves both tan and cot with different angles, then we express them in terms of sine and cos, both. Okay. If an equation involves tan and cot with different angles, suppose one is tan theta and another is cot 2 theta. Okay, one is tan theta, another is cot 2 theta. So tan is with theta and cot is with 2 theta. In that case, we write tan theta as sin theta by cos theta and cot 2 theta as cos 2 theta by sin 2 theta. That means we will express them in terms of sine and cos. But if they are with the same angle, then tan will remain as tan and cot will be expressed as 1 by tan. Remember these points. Okay, so these are the points to be remembered. Next, there is a spatial form. I will discuss how to solve a spatial form. If we get an equation of the form a cos theta plus b sin theta is equal to c. What will we do? We will divide both sides with root over a square plus b square. Okay, so a by root over, it will become a by root over a square plus b square cos theta plus b by root over a square plus b square sin theta is equal to c by root over a square plus b square. Now we will express this one as cos of some angle, and that will be a sine of the same angle. Okay, for our understanding, let us take an example. Here is the example. Sin x plus root 3 cos x is equal to root 2. This is of the form something into sine, theta into place of theta here written x, no problem, x is the variable, here theta is the variable. So something into sine plus something into cos is equal to something. A cos theta plus b sin theta is equal to c. A cos theta plus b sin theta is equal to c. There may be minus also, no problem. So what will you do here? A is root 3 and b is 1. We will divide both sides by a square plus b square. A square plus b square. That means 3 plus 1. Root over 3 plus 1. That means 2. We will divide both sides by root over a square plus b square. That means we have to divide here with 2. So this will become half sin x plus root 3 by 2 cos x is equal to root 2 by 2. Alright. Now you have to write the coefficient of sin x in terms of sine. So half can be written as sin pi by 6 sin 30 into sin x plus root 3 by 2 as cos pi by 6 into cos x is equal to 1 by root 2. Now this is cos x cos pi by 6 plus sin x sin pi by 6 is equal to 1 by root 2. Now what is this? Cos A cos B plus sin A sin B, that is cos of A minus B. This will imply cos of x minus pi by 6 is equal to cos 1 by root 2 means what? Pi by 4. Cos pi by 4. Now this is of the form cos theta is equal to cos alpha. What is the general solution for cos theta is equal to cos alpha? That means theta is equal to, what is our theta here? X minus pi by 6. So the general solution is theta is equal to twice and pi plus or minus alpha. What is alpha here? Pi by 4. So we have to find the solution, general solutions. That means we have to find the value of x. This implies x equal to twice and pi plus minus pi by 4 plus pi by 6 and belongs to z. Now therefore x equal to twice and pi. If we take plus sign here, this will be plus pi by 4 plus pi by 6. Okay. So by taking LCM of 4 and 6 is 12, and this will be 2 pi, this will be 3 pi, so this will be 5 pi by 12. Or x equal to twice and pi. If we take minus sign here, okay, this will be minus pi by 4 plus pi by 6. That means minus 3 pi plus 2 pi. That means minus pi by 12. Taking LCM. So these are the general solutions. Okay. So these are the solutions. So what is the rule? If it is of the form a cos theta plus b sin theta, b may be negative also, a may be negative, no problem, c may also be negative. We divide both sides by root over a square plus b square. After dividing, coefficient of sin x is written in terms of sine, coefficient of cos x is written in terms of cos. Then apply some formula. There will always be cos a cos b plus sin a sin b, or cos a cos b minus sin a sin b. So it will be cos of something equal to, here will be some value. Here you have to remember one more thing. Suppose instead of 1 by root 2, if this is root 3, okay, if we have got cos x minus pi by 6 equal to root 3, now this equation will be invalid because root 3 is greater than 1 and we know that value of cos x is always less than equal to 1. So this will be invalid equation, and so we will just write this is impossible and we leave it. Okay, in that case we will leave it. If there is some illogical things comes, we will leave the equation. So this is the rule. Now let us solve some examples. Let us apply. Let us apply the formula here. So, what are the rules? First rule is whatever equation is given, you have to express the equation in form of sin theta is equal to sin alpha, or cos theta is equal to cos alpha, or tan theta is equal to tan alpha. So our next example is 2 cos square theta minus 3 cos theta plus 1 equal to 0. Okay. Is this in the form of sin theta is equal to sin alpha, or cos theta is equal to cos alpha, or tan theta is equal to tan alpha? No. So we have to express it. What can we do? Let us factorize it. Okay, on factorization, okay, let us go 2 cos square theta, 2 into 1 is 2, so this will be minus 2 cos theta minus cos theta plus 1 equal to 0. If we take 2 cos theta common here, so cos theta minus 1, minus is common, cos theta minus 1 equal to 0. Taking cos theta minus 1 common, there will be 2 cos theta minus 1 equal to 0. So this into this equal to 0, that means either this part equal to 0 or that part equal to 0. Therefore, cos theta minus 1 equal to 0 or 2 cos theta minus 1 equal to. This will imply cos theta is equal to 1. Now what is the general solution of cos theta is equal to 1? General solution of cos theta is equal to 1 is theta is equal to twice n pi. So theta is equal to twice n pi. Don't forget to write n belongs to z. This is very important. Okay. So one solution we have got, theta is equal to twice n pi. This implies 2 cos theta is equal to 1. This will imply cos theta is equal to half. So cos theta is equal to what? Half means cos pi by 3 cos 60. Now this is in the form cos theta is equal to cos alpha. This is also in the form cos theta is equal to cos alpha. One may be written as cos 0. Okay. So we have to reduce this one over our standard form. Cos theta is equal to cos pi by 3. That means cos theta is equal to cos alpha. So theta is equal to twice n pi plus minus pi by 3 n belongs to z. Therefore the general solutions are so what are the general solutions? Theta is equal to twice n pi, n belongs to z, or twice n pi plus minus pi by 3, n belongs to z. Let us take one more example. Next question is cot x minus tan x equal to 2. Cot x minus tan x equal to 2. So this is an example where the equation involves both cot and tan with the same angle. If the equation involves both cot and tan with same angle, then what we do? We reduce cot in terms of tan. So we write cot x as 1 by tan x minus tan x equal to 2. This implies 1 minus tan square x equal to 2 tan x. Okay. Now You remember the formula for tan twice a? Formula for tan twice a is 2 tan a by 1 minus tan square a. If we divide this by 1 minus tan square a, we will get the formula. So we will divide both sides with respect to 1 minus tan square x. 2 tan x by 1 minus tan square x. Dividing both sides by 1 minus tan square x. This implies 1 is equal to tan twice x. Implies tan twice x is equal to 1. This is of the form tan theta is equal to 1. What is the general solution for tan theta is equal to 1? Theta is equal to 4n plus 1 pi by 4, n belongs to z. You are to find the solution, that means you are to find the value of x. So what will be the value of x? X will be 4n plus 1 pi by 8, n belongs to z. Okay, let's take the next question. Next equation is tan theta plus tan 2 theta plus root 3 tan theta tan 2 theta is equal to 2. So how to arrange this? How to simplify? This is very important. How can you simplify this? For simplification, you must have to remember the formula. Tan a plus tan b divided by 1 minus tan a tan b is equal to tan of a plus b. So, if we bring this quantity to the right hand side and take root 3 common, there will be 1 minus tan theta tan 2 theta, and this will take the form tan a plus tan b divided by 1 minus tan a tan b. So, tan theta tan 2 theta, taking this to that side and root 3 is taken common, this will be 1 minus root 3 into 1 minus tan theta into tan 2 theta. Now we divide both sides by 1 minus tan theta into tan 2 theta. There will be tan theta plus tan 2 theta divided by 1 minus tan theta tan 2 theta is equal to root 3. This is tan a plus tan b divided by 1 minus tan a tan b, that means tan of a plus p is equal to root 3. This implies tan 3 theta is equal to root 3. This implies tan 3 theta is equal to root 3. Root 3 means tan 60. That means tan of pi by 3. Now this is of the form tan theta is equal to tan alpha. What is theta here? Theta means 3 theta. So theta is equal to n pi. What is the general solution of tan theta is equal to tan alpha? Theta is equal to n pi plus alpha. N belongs to z. So the general solution is n pi by 3 plus pi by 9 belongs to z. Okay, let us take the next equation. Sin 5 theta plus sin theta is equal to sin 3 theta. Okay, so our equation is sin 5 theta plus sin theta is equal to sin 3 theta. Alright. So there are 3 angles. In case of 3 angles, what do we take? We always take 2 angles whose sum or difference is double the third. We consider 2 angles whose sum or difference is double the third and apply C plus D or C minus D formula. So here 5 theta plus theta is 6 theta, which is double of 3 theta. So we will apply here sin C plus sin D. What is the formula for sin C plus sin D? 2 sin C plus D by 2 into cos C minus D by 2 is equal to sin 3 theta. This implies 2 sin 3 theta into cos 2 theta is equal to sin 3 theta. Here comes the rule for cancellation. You may cancel sin 3 theta But in that case, you will lose the solutions of sin theta is equal to 0 if it satisfies the equation. Okay. If sin theta is equal to 0, that means theta is equal to 0 means theta is equal to 0. Does it satisfy the equation? Let's see. Sin 0, 0 plus sin 0, 0, 0 plus 0 is 0. So our left hand side is 0. Right hand side is also 0. So it's satisfying the equation. You cannot cancel. So what will we do? We will take sin theta common. We bring that sin theta to this side, left hand side, and take sin theta common. Don't cancel it, otherwise you will lose a set of solutions. Okay? So either sin theta is equal to 0 or cos 2 theta minus 1 equal to 2 cos 2 theta minus 1 equal to 0. So the solution of sin theta, this is the form sin theta is equal to 0, sin theta is equal to 0 implies theta is equal to n pi, n belongs to z, implies theta is equal to n pi by 3, n belongs to z. And this implies 2 cos 2 theta is equal to 1. This implies cos 2 theta is equal to half. This implies cos 2 theta is equal to cos pi by 3, cos 60 is half. Now this is of the form cos theta is equal to cos alpha, and whose general solution is theta is equal to twice n pi plus minus alpha. So twice n pi plus or minus alpha, n belongs to z. Now what is the value of theta? Dividing by 2 we get n pi plus minus pi by 6, n belongs to z. Dividing by 2, theta is equal to n pi plus minus pi by 6, n belongs to z. So what our general solutions are? Theta is equal to n pi by 3 or theta is equal to n pi plus minus pi by 6, n belongs to z. So let's take the next equation. Next equation is 2 cos square theta plus 4 sin square theta is equal to 3. 2 cos square theta plus 4 sin square theta is equal to 3. Okay. Here you see 2 cos square theta plus 4 sin square theta is equal to 3. The equation involves both sin theta and cos theta. Okay, but we have to approach only one, either sin theta or cos theta or tan theta. So either we will reduce the equation to sin of sin theta is equal to something, or cos theta is equal to something, or tan theta is equal to something. For that, if we approach for cos theta is equal to something, we will reduce sin square theta as 1 minus cos square theta. If we like to go for sin theta, we will reduce cos square theta as 1 minus sin square theta. But in between sin and cos, we always prefer cos, because the solution structure of cos is more simple than that of sin. Cos theta is equal to cos alpha has the structure twice n pi plus minus alpha. Theta is equal to twice n pi plus minus alpha. But sin theta is equal to sin alpha is theta is equal to n pi plus minus 1 to the power n into alpha. And that minus 1 to the power n is something very complex. It disturbs in further simplifications. So we will try to avoid sin theta is equal to sin alpha. If there is an option for cos theta is equal to cos alpha, we prefer cos theta is equal to cos alpha. So we will go for cos theta is equal to cos alpha. So this is 2. If an equation can be reduced to both sin theta is equal to sin alpha and cos theta is equal to cos alpha, we prefer cos theta is equal to cos alpha. We prefer cos theta is equal to cos alpha. So we will reduce the equation to cos. So we will write 1 minus cos square theta for sin square theta. Now on simplification, 2 cos square theta plus 4 minus 4 cos square theta is equal to 3. This implies 2 minus 4 cos square theta is minus 2 cos square theta is equal to 3 minus 4. This gives 2 cos square theta is equal to 1. Okay. There is a chance here 2 cos square theta minus 1 is equal to cos twice theta. So we may take it, or else you can take cos theta is equal to cos square theta is equal to half, cos theta is equal to plus minus half. In that case, you will have to solve two equations. But if you take a smart step, 2 cos square theta minus 1 equal to 0, then this will give you cos twice theta is equal to 0. Okay. So defined approaches leads to defined solutions. Okay. If you go for cos theta is equal to cos square theta is equal to half, cos theta is equal to plus minus 1 by root 2. In that case, you will get two solutions. One is for cos theta is equal to 1 by root 2 and another for cos theta is equal to minus 1 by root 2. But in my approach, I will get only one solution. Okay. That's why I told you defined approach will lead to defined solutions which will differ in looks, but the solution set as a whole is the same. So this is cos theta is equal to 0. What is the general solution for cos theta is equal to 0? General solution for cos theta is equal to 0 is theta is equal to twice n plus 1 pi by 2 n belongs to z. This implies theta is equal to twice n plus 1 pi by 4 n belongs to z. So this is our general solution. So this is an example where we will have different approaches. You may even reduce this equation to tan theta is equal to tan alpha. Dividing the whole equation by cos square theta, you will get 2 plus 4 tan square theta is equal to 3 sec square theta. Again writing 1 plus tan square theta for sec square theta. The equation will contain tan only, and ultimate form will be tan theta is equal to tan alpha. Let us take the next question. So our next equation is tan ax plus cot bx equal to 0. Tan ax plus cot bx equal to 0. It is given that a is not equal to b. So this is an example where the equation involves both tan and cot, but with defined angles. One angle is ax and another angle is bx. So what will we do? We will reduce both tan and cot to sin and cos. That was the rule. So tan ax can be written as sin ax by cos x and cot as sin bx, so cos bx sin bx. Taking LCM, sin x sin bx plus cos x cos bx divided by cos x into sin bx is equal to 0. On cross multiplication, we will write cos first. Cos x into cos bx plus sin ax into sin bx equal to 0. Cross multiplication. This is of the form cos a cos b plus sin a sin b, which can be written as cos of a minus b is equal to 0. So this is of the form cos theta is equal to 0. And the general solution for cos theta is equal to 0 is theta is equal to twice n plus 1 pi by 2 n belongs to z. This implies taking x common, a minus b into x equal to twice n plus 1 pi by 2 n belongs to z. This implies x equal to twice n plus 1 by a minus b pi by 2 and belongs to z. So this is our general solution. The variable may be theta or x or anything. Okay, you should not bother that. Then there is another example. So example is sin square x minus 5 sin x into cos x minus 6 cos square x equal to 0. So what will you do? We will divide the whole equation by cos square x, so that we get 10x. So dividing by cos square x, sin square x by cos square x equal to 10 square x. Sin x cos x by cos square x is sin x by cos x, that means 10x minus 6 equal to 0. Now this equation contains 10 only. Okay, in that case there was sin and cos both. Okay, having sin cos both is a double sum. So we prefer only one ratio, so this is 10 only. Now let us factorize it. 10x minus 2 into 10x minus 3 is equal to 0. Oh. How is this possible? Minus 6 cos square x equal to 0, yeah. Right. No, there is something wrong. 5 right now. Minus 6. Okay. So this will be 10x plus 1 into 6 ones are 6. 10x minus 6 equal to 0. So this is the factorized form. Therefore, either 10x plus 1 equal to 0 or 10x minus 6 equal to 0. This gives 10x equal to minus 1. And what is the general solution for 10x equal to minus 1? Tan theta is equal to minus 1 gives theta is equal to 4n minus 1 pi by 4, n belongs to z. Now what's about this? 10x equal to 6. Here is something to learn. 10x equal to 6. But in our table, we don't have the value 6. This is not a standard value. Then we have to think that, is it possible that the value of 10x is 6? Yes. 10x may take any value from minus infinity to plus infinity. So 10x equal to 6 is possible. The case is that, matter is that we don't know 10 of what angle is 6. What will you do in that case? We'll write it this way, we'll approach in this way. We'll write 10x equal to 10 alpha, where 10 alpha is equal to 6. Okay, if the angle is unknown but the possible value is there, then we will write in this way. 10 alpha is equal to 6. This will give, this is of the form tan theta is equal to 10 alpha, theta is equal to n pi plus alpha, n belongs to z, and you will explain here that where what is alpha? Alpha is such an angle that tan alpha is equal to 6. Okay, you have to mention it in the answer. Now, okay, up to this in this video. Now, time for homework. You solve in your class book exercise 3.3. These are your homeworks. Class book exercise 3.3, question number 4, then 5, then 6, 8, 9, 12, 12, then 13, 15. Okay, let it be after 15. Okay, this is up to, so your homework is class book up to 15, and then from NCERT exercise 3.4. NCERT exercise 3.4. So these are your homeworks, and goodbye till the next video.